Okay, so here's an explanation of the homework. Let's get you started. Make sure you guys know what we're doing here. If we take a look at number 1, they want us to determine which of the following ordered pairs are part of the solutions to this inequality. Okay, so just keep in mind, these are coordinates. They're really x and y values. All you have to do, Austin, is plug in the 4 in for x and the 3 in for y. So if you plugged in a 4 right here, 3 times 4 is 12. 12 plus, if you plug in a 3 for y, 12 plus 3 is 15, and that's definitely greater than 6. Now, it doesn't have to be equal to 6. It could be equal to 6. That's why there's greater than or equal to 6. So yeah, 15 is definitely greater than 6, so this works. All you got to do is plug it in and see if it works. If it doesn't work, then you know it's not an answer. So if you plug in this one, check it out. This one has x being negative 2 and y being 4. So if you do plug in a negative 2 right here, that's going to give you negative 6. Because 3 times negative 2 is negative 6. And when you go plus y, when y is 4, that's going to give you a negative 2. So if you think about it, negative 2 is definitely not greater than or equal to 6. Negative 2 is less than 6. So let me erase this. So negative 2 is not greater than 6. So we know that the second coordinate is not an answer. I would cross it out. Okay? Now if you try the other ones, plug in a negative 5 for x, that'll be negative 15, plus a negative 3, that's negative 18. Negative 18 is definitely not greater than 6. It's a negative number. It's smaller than any positive number. So again, if I plug in negative 5 and negative 3, it's going to give you negative 18, and that's false. Negative 18 is not greater than or equal to 6. So that next one does not work either. Okay. How about that last one? If I plug in a 3 right here, that's going to be 3 times 3 is 9. Let me jot that down so we can keep track. 3 times 3 is 9. And then we plug in negative 3 for y right here. So that's going to be plus negative 3. Let me write that out just so we could see it. Plus negative 3. So what's 9 plus negative 3? 6. Is 6 greater than or equal to 6? Yes, it's equal to 6. So this one does work. So our answers, or the ordered pairs that work, this one works and also this one works. The two middle ones do not work. So that's how you do numbers 1, 2, and 3. All you're doing is testing points to see if they work. Maybe none of them work. Maybe all of them work. There technically is an infinite amount of points that work. So that's the first part. Let's move on to the second part. This is the fun part where you actually have to go through the steps on your notes to be able to graph it. Step 1 is to get y by itself. Let me jump to number 5. Step 1 is to get y by itself. So you could have y equals mx plus b. So what are we going to do first? Minus 2x. Thank you very much. And what you do to one side, you do to the other side. So we're going to rewrite this thing. Negative 2y is greater than or equal to negative 2x plus 8. And now after that, we need to get rid of that negative 2 in front of the y. So what do? Divide by negative 2. So let's divide by negative 2. Divide by negative 2, divide by negative 2. So our final slope-intercept form inequality will be y by itself greater than or equal. Oh no, I'm sorry. That's a mistake right there. It's not greater than or equal to. It's actually what? Less than or equal to. So why did I have to flip it? Because I divided by a negative. Now, if you don't divide by a negative, like if I would have just divided by 2, divided by 2, divided by 2, you don't flip it, you just bring it down. But because you divided by a negative on your last step, you have to flip that inequality symbol. So what do I have left? I have 1x. You could put 1 over 1 if you want. And most of the time I write my slope in blue. Let me do that. And then at the very end, I have 8 divided by negative 2. That is negative 4. And most of the time I write my b value in red. So again, our m value is 1 over 1, and our b value is negative 4. So there's my y equals mx plus b equation, or actually, slope-intercept form inequality. Yes, bless you, sorry about that. So now that we have the slope-intercept form inequality, now I could graph. Again, I start graphing by going to my b value, which is negative 4. So let's go down to negative 4. 1, 2, 3, 4. Put a dot right there. Now from that dot, do I rise or do I drop? You rise. How much do you rise? 1. How much do you run? So from here I go up 1 and run 1. Rise 1, run 1. Rise 1, run 1. Now, of course, you're only putting dots after you rise and run right here. And rise and run right here and here and here. And you could keep going, especially because inequalities, you have to make them as long as the graph is. You have to, not only that, let's go in the opposite direction as well. So instead of rising 1, running 1, let's go backwards. 1 this way, 1 this way, 1 this way, 1 this way. That way you could get the graph from one side of the graph, or the line from one side of the graph to the other. Now, is this going to be a solid line or a dotted line?
Solid.
Why solid?
Line.
There's a line underneath the inequality, so it's going to be a solid line. So let's actually draw a solid line. Arrows. Now we need to show where all of the answers are at. They're either going to be on this side of the line or on the other side of the line. Okay? So we need to test a point. What point are we going to test?
0,
0,
0.
0.
0, 0.
Okay. Why 0, 0? Because it's the easiest one. Now, unless your line, like let's say you had this as a line and it's actually going through 0, 0, then you couldn't use 0, 0. Okay? Because you need a point that's clearly on one side of the line or the other. Okay, but that, let me erase that. So we don't really have a line like this. But if it did go through the origin, you don't want to mess with 0, 0 because it's not going to help you. So in this case, we can use 0, 0. It's the easiest point to use. So we're going to test this guy right here. If it works, I shade in everything up here. If it doesn't work, that means that my answers are on the other side and I shade in everything down here. So it all depends if it works or if it doesn't work. So you could plug it in to the new slope-intercept form, or you could plug it in even if you wanted to the original, whatever you want. So 0, 0, do you want to plug it in on the original, which is here and here, or on the new modified slope-intercept form one? Let's do both. If I plug in a 0 here, what's 2 times 0?
0.
What's 2 times 0? What's 0 take away 0? So what we really have is 0 is greater than or equal to 8. What do you think of that? False. Does not work. So 0, 0, this point does not work, right? So if that doesn't work, it means it's not an answer. So where are our answers at? On the other side. So we shade in the other side. Shade, shade, shade. If you have a highlighter, it's a good time to use a highlighter, right? And that's it. Pick one. 9. Oh, dang. That's an ugly one. It's ugly. What's ugly about this one? Fractions. I guess we could temporarily get rid of fractions by multiplying everything by what? By 2? How about that? Let's try it. Let's see what happens. Let's mess with this guy. Let's multiply by 2, multiply by 2, multiply by 2, multiply by 2, everything by 2. We're going to end up with a 2y. We're going to end up with a plus 1. We're going to end up with a greater than. We didn't multiply by a negative, so I don't have to flip it. 2 times negative 2 is negative 4 with an x. And then the 2's cancel. We have a plus 7. Okay, so now let's start getting the y by itself. So what do I do next? Subtract 1, subtract 1. Okay, so we're going to have a new equation, inequality, that says 2y is greater than negative 4 plus 6. Oh, negative 4x, I'm sorry, plus 6. So what's my final step? Divide by 2, divide by 2, divide by 2. Do I flip the inequality symbol? No, I do not. Okay, so let me just rewrite it. Y is greater than negative 4 divided by 2. You could write it as negative 2 or negative 2 over 1, of course, with an x. And then plus 6 divided by 2, that's going to be a plus 3. And now you could clearly see your slope-intercept form inequality. It crosses at 3, and you go down 2 over 1 from that point. So let's cross at 3. Let's put a dot at 3 on the y. And from that point, let's go down 2 over 1. And we could continue to go down 2 over 1, down 2 over 1, down 2 over 1, and down 2 over 1 to make it from one side of the graph to the other. And of course, you could go backwards. Instead of down 2 over 1, you could go backwards over 1 this way and up 2 to get it to the other, to extend it the other way. So is this going to be a solid line or a dotted line? Dotted. Okay, so let's put some dots or some dashed, as long as it's not a solid line. Here's my dotted line. Put some arrows on it. And now we need a shade. Our answers are either going to be on one side of this thing or on the other side of this thing. Andrea, what coordinate would you like to test? 0, 0. Correct. 0, 0 is the best, especially when it's not on the line. So if we test this point, the origin, 0, 0. Now again, you could test it right here. 0 is greater than, this is 0 plus 3. So if you think about that, 0 is greater than 3. True or false? 0 is not greater than 3. That's false. Okay, so this does not work. You'd have to shade in the other side. Or you could go back to the original and you could plug them in. Yeah, but the original is ugly. So yeah, this is the best one to plug in. Plug in a 0 for x, a 0 for y. It's going to say 0 is greater than 3. That's false, which means that this point origin does not work. So where are our answers at? They're on the other side, so you shade in up here, all of this up here. This will be on next Friday's test. Okay, not this quiz Friday, but next Friday's test. Please make sure you understand it and you finish this homework assignment.